The use of so-called for control wiring is generally not allowed in commercial buildings due to safety concerns, even if it is part of the equipment. Several reasons contribute to this prohibition. Firstly, insufficient durability exists, so cord is not as durable as other types of wiring, such as electrical metallic tubing, or IMT, or liquid-tight conduit. It is prone to damage from physical impact, abrasion, and heat. Secondly, a potential for overheating occurs, so cord has a limited current carrying capacity, which can lead to overheating if it is overloaded. Thirdly, fire hazard. Damaged so cord can create a fire hazard. Fourthly, code violations. Code requirements such as Article 400.8 of the National Electrical Code, also known as NEC, prohibit the use of flexible cords as permanent wiring. However, there is a potential loophole that may allow the use of the factory-supplied cord for control wiring under certain conditions. Section 400.84 of the NEC allows the use of flexible cords when used for portable equipment for industrial use. It could be argued that the trash compactors are portable equipment for industrial use because they are not permanently fixed and are intended for use in industrial settings. This loophole would only apply to the factory-supplied cord that is part of the equipment and is not used for extensions or field wiring. However, it is important to note that the inspector has the final say on the acceptability of any installation. The loophole is subject to interpretation and may not be accepted by all inspectors. It is generally considered best practice to avoid using cord for permanent control wiring in commercial buildings. To ensure compliance with code requirements and avoid potential hazards, it is recommended to follow the inspector's instructions and replace the cord with electrical metallic tubing, or IMT, and liquid-tight conduit, as requested in the change order. In more detail, let's explore Article 400.8 of the National Electrical Code. This section specifically addresses the uses not permitted for flexible cords and flexible cables. It is crucial to understand these restrictions to ensure electrical installations are safe and compliant. The general rule is that flexible cords and cables should not be used for permanent wiring. This means they are not intended to be a substitute for the fixed wiring of a structure. Now let's dissect the specific prohibitions listed under 400.8. Flexible cords and cables are not permitted to be used as a substitute for the fixed wiring of a building or structure. This is because they are not designed to withstand the same environmental conditions and physical stresses as permanent wiring methods like electrical metallic tubing, or IMT, rigid conduit, or cable assemblies designed for fixed wiring. These cords and cables cannot be run through holes in walls, structural ceilings, suspended ceilings, drop ceilings, or floors. This is to prevent damage to the cord or cable from sharp edges or physical strain, which could lead to electrical hazards. Flexible cords and cables also cannot be run through doorways, windows, or similar openings. These areas are subject to frequent movement and can cause abrasion or pinching of the cord or cable, again increasing the risk of damage and electrical hazards. Attaching flexible cords and cables to building surfaces is not allowed. This includes fastening them with staples, cable ties, or any other method that would secure them in place like permanent wiring. Flexible cords and cables are designed to be flexible and movable, and attaching them to building surfaces defeats this purpose and can lead to damage. Concealing flexible cords and cables behind building walls, structural ceilings, suspended ceilings, or floors is prohibited. This is because concealed cords and cables are not readily accessible for inspection and maintenance, making it difficult to detect potential problems like overheating or insulation damage. Now let's dive into the exceptions to these rules. The NEC does recognize certain situations where flexible cords and cables can be used, even in applications that might seem to violate the general prohibitions. These exceptions are carefully defined and must be strictly adhered to. Flexible cords and cables can be used for pendants. Pendants are light fixtures that are suspended from the ceiling by a cord. The flexible cord allows the fixture to be easily adjusted and moved. Flexible cords and cables can be used for wiring of fixtures where the weight of the fixture or the need for flexibility prevents the use of fixed wiring methods. This exception is often used for lighting fixtures in industrial settings where the fixtures may need to be repositioned frequently. Flexible cords and cables can be used for connection of appliances where the fastening means and mechanical connections are designed to permit ready removal for maintenance and repair, and the appliance is intended or identified for flexible cord connection. This exception allows for the use of flexible cords for appliances like refrigerators, washing machines, and portable air conditioners, which need to be easily disconnected for servicing. Flexible cords and cables can be used for data processing cables as permitted by 645.5. Section 645.5 of the NEC outlines specific requirements for wiring in information technology equipment rooms, and it allows for the use of flexible cords and cables under certain conditions. Flexible cords and cables can be used for connection of moving parts. This exception applies to equipment with moving parts, such as machinery and tools, where the flexible cord allows for the necessary movement without straining the wiring. Flexible cords and cables can be used for temporary wiring as permitted in 590.4. Article 590 of the NEC covers temporary wiring installations, such as those used during construction or for carnivals and fairs. It allows for the use of flexible cords and cables under specific conditions and for a limited time. Flexible cords and cables can be used for elevator cables. Elevators require flexible cables to allow for the movement of the elevator car within the hoistway. The NEC has specific requirements for elevator wiring in Article 620. Flexible cords and cables can be used for wiring of cranes and hoists. Cranes and hoists also require flexible cables to allow for the movement of the lifting mechanism. Article 610 of the NEC covers the wiring of cranes and hoists. Flexible cords and cables can be used for connection of portable equipment. This exception is particularly relevant to the scenario of trash compactors. If the trash compactors are considered portable equipment for industrial use, the factory-supplied SO cord may be permitted. Now let's focus on the specific exception that might apply to the use of SO cord with trash compactors. Section 400.84 allows for the use of flexible cords when used for portable equipment for industrial use. The key here is whether the trash compactors can be classified as portable equipment for industrial use. Consider these factors when making this determination. Are the trash compactors designed to be easily moved from one location to another, or are they intended to be permanently installed? If they are designed to be easily moved, this supports the argument that they are portable. Are the trash compactors used in an industrial setting such as a factory, warehouse, or manufacturing plant? If they are used in such a setting, this supports the argument that they are for industrial use. It's important to note that even if the trash compactors meet these criteria, the final decision rests with the electrical inspector. The inspector has the authority to interpret the NEC and determine whether the use of SO cord is acceptable in the specific installation. Therefore, it is always best to consult with the inspector before using SO cord in this type of application. The types of flexible cords and cables commonly used in electrical installations, each with its own specific applications and limitations. Understanding the characteristics of these cords and cables is essential for selecting the right one for a particular job. Let's start with SO cord, which has already been discussed. SO cord is a type of flexible cord that is commonly used for portable tools, appliances, and equipment. The letters SO stand for service oil resistant. This means that the cord is designed to withstand exposure to oil and other chemicals. SO cord is typically made with stranded copper conductors and a rubber or thermoplastic insulation. It is available in a variety of sizes and conductor counts. SJO cord is similar to SO cord, but it is rated for less severe service. The J in SJO stands for junior. SJO cord is typically used for lighter duty applications such as portable lamps and small appliances. It is also available in a variety of sizes and conductor counts. SD cord is a type of flexible cord that is designed for use in damp or wet locations. The T in SD stands for thermoplastic. SD cord is typically made with stranded copper conductors and a thermoplastic insulation that is resistant to moisture. It is commonly used for outdoor applications such as extension cords and portable power tools. SJT cord is similar to SD cord, but it is rated for less severe service. Like SJO cord, the J in SJT stands for junior. SJT cord is typically used for lighter duty applications in damp or wet locations such as portable lamps and small appliances. It is also available in a variety of sizes and conductor counts. Now let's explore the types of flexible cords and cables that are commonly used in electrical installations. Type W portable power cable is a heavy-duty cable that is designed for use in industrial and construction applications. It is typically made with stranded copper conductors and a thermoset insulation that is resistant to abrasion chemicals at extreme temperatures. Type W cable is commonly used for welding machines, portable generators, and other high-power equipment. Welding cable is a type of flexible cable that is specifically designed for use with welding machines. It is typically made with stranded copper conductors and a thermoset insulation that is highly flexible and resistant to heat and abrasion. Welding cable is available in a variety of sizes to accommodate different welding currents. Festoon cable is a type of flexible cable that is used to supply power and control signals to moving equipment such as cranes, hoists, and automated machinery. Festoon cable is typically suspended from a trolley system that allows it to move along with the equipment. It is designed to withstand the constant bending and flexing that occurs during operation. Control cable is a type of multi-conductor cable that is used to transmit control signals between different pieces of equipment. Control cable is typically made with stranded copper conductors and a thermoplastic or thermoset insulation. It is available in a variety of sizes and conductor currents to accommodate different control systems. Instrumentation cable is a type of multi-conductor cable that is used to transmit low-level signals from sensors and instruments. Instrumentation cable is typically shielded to protect the signals from electrical noise and interference. It is commonly used in industrial process control systems and laboratory equipment. Data cable is a type of multi-conductor cable that is used to transmit digital data between different devices. Data cable is available in a variety of types, including Ethernet cable, USB cable, and coaxial cable. Each type of data cable is designed for a specific data transmission protocol. The National Electrical Code, or NEC, provides specific guidelines for the selection and use of flexible cords and cables in different applications. Some of the key NEC articles that address flexible cords and cables include Article 400, which covers the general requirements for flexible cords and cables, including permitted uses, ampacity ratings, and installation methods. Article 590, which covers temporary wiring installations, including the use of flexible cords and cables for temporary power and lighting. Article 610, which covers the wiring of cranes and hoists, including the use of flexible cables for power and control. Article 620, which covers the wiring of elevators, including the use of flexible cables for power and control. Article 645, which covers wiring in information technology equipment rooms, including the use of flexible cords and cables for data processing equipment. It is essential to consult the NEC and other relevant standards to ensure that flexible cords and cables are selected and installed correctly. Now let's move on to the installation requirements for flexible cords and cables. Proper installation is crucial for ensuring the safety and reliability of electrical systems. Before installing any flexible cord or cable, it is important to inspect it for damage. Look for any cuts, abrasions, or other signs of damage to the insulation. If the cord or cable is damaged, it should not be used. Flexible cords and cables should be supported properly to prevent strain on the connections. This can be done by using cable ties, clamps, or other suitable methods. The support should be spaced close enough to prevent the cord or cable from sagging or touching any sharp edges. Flexible cords and cables should be protected from physical damage. This can be done by routing them away from high-traffic areas and protecting them with conduit or other protective materials. Flexible cords and cables should not be run through walls, floors, or ceilings unless they are specifically designed for this purpose. Running flexible cords and cables through these areas can create a fire hazard and make it difficult to access them for maintenance. Flexible cords and cables should be connected to devices and equipment using approved methods. This may involve using cord connectors, strain relief devices, or other specialized fittings. The connection should be made tightly and securely to prevent loose connections and arcing. Flexible cords and cables should be used within their rated ampacity. Overloading a flexible cord or cable can cause it to overheat and create a fire hazard. The ampacity rating of the cord or cable is typically marked in the jacket. Flexible cords and cables should be protected from moisture and chemicals. Exposure to moisture and chemicals can damage the insulation and conductors, leading to electrical hazards. If the cord or cable is used in a damp or wet location, it should be specifically rated for this purpose. Flexible cords and cables should be stored properly when not in use. This can be done by coiling them neatly and storing them in a dry location. Avoid storing flexible cords and cables in direct sunlight or near heat sources. Now let's consider some of the common mistakes that people make when working with flexible cords and cables. Avoid using flexible cords and cables as a substitute for permanent wiring. As mentioned earlier, flexible cords and cables are not designed to withstand the same environmental conditions and physical stresses as permanent wiring methods. Avoid overloading flexible cords and cables. This is one of the most common mistakes that people make. Overloading a flexible cord or cable can cause it to overheat and create a fire hazard. Avoid running flexible cords and cables through walls, floors, or ceilings. This can create a fire hazard and make it difficult to access them for maintenance. Avoid using damaged flexible cords and cables. If the cord or cable is damaged, it should not be used. Avoid exposing flexible cords and cables to moisture and chemicals. This can damage the insulation and conductors, leading to electrical hazards. Avoid storing flexible cords and cables improperly. This can damage the cord or cable and shorten its lifespan. Let's reiterate the importance of consulting with a qualified electrician before performing any electrical work. Electrical work can be dangerous, and it is important to have the knowledge and experience to do it safely and correctly. A qualified electrician can help you select the right flexible cords and cables for your application, install them properly, and ensure that your electrical system is safe and compliant with the NEC and other relevant standards. The electrical inspector's role in ensuring code compliance is a critical aspect of electrical safety. Electrical inspectors are responsible for enforcing the NEC and other local electrical codes. They review electrical plans, inspect electrical installations, and issue permits to ensure that electrical work is done safely and in compliance with the code. The electrical inspector has the final say in the acceptability of any electrical installation. Even if you believe that your installation meets the requirements of the NEC, the inspector can still reject it if they have concerns about its safety or compliance. It is important to work with the electrical inspector and address any concerns that they may have. The electrical inspector can provide guidance on how to correct any deficiencies and ensure that your installation is compliant. If you disagree with the electrical inspector's decision, you have the right to appeal their decision. However, it is important to understand the appeals process and to present your case in a professional and respectful manner. Compliance with electrical codes is essential for ensuring the safety of people and property. By following the NEC and other relevant standards, you can minimize the risk of electrical hazards and ensure that your electrical system is safe and reliable.